Hey everyone, so today we're going to be doing vectors and more specifically vector proofs. We haven't done vectors before, but I realized that proving is one of the weak points amongst majority of students. So that's why we're going to get into it. And today we're going to go through one specific proving, and that is collinearity. Proving that 3 points, or usually it is 3 points, that they are collinear. What does collinear mean? So that is when you have, in our case, 3 points. Collinear means they're on the same line. So linear, that's a line. Co means together. So in this case, you have 3 points, and if you were to draw a line together, it would join all 3 points together. So that's what collinear means. So how do you prove that these 3 points using vectors are collinear? We have to satisfy 2 criteria. So in this case, the first criteria is that you have 2 vectors. So 2 vectors with a common point. Now what I mean by that is you have one vector, so let's just call this point A, this point B, and this point C, right? So if you want to prove collinearity, the first criteria is you have 2 vectors. You can call that vector AB. So we have vector AB, and you can have vector maybe BC, or AC, or BC. So if we take AC, that means we have 2 vectors, AB and AC, and they have a common point A. Or if you take AB and BC, then their common point will be B. And of course, you can also have AC and BC, where the common point will be C. So it's your choice, doesn't matter which 2 vectors, as long as you have 2 vectors with a common point. And of course, that's criteria 1. Criteria number 2, which is the most important one here, is that your 2 vectors, the one that you chose in part 1, are parallel. So if you were to pick AB and AC, these 2 vectors, then AB and AC have to be parallel. So how does that work? Let's look at 2 different scenarios. You have point A, point B, and let's just say point C over here. So A to B would have this vector, and A to C would have this vector. So they satisfy the first criteria. They have a common point at A, and there are 2 vectors, but it doesn't satisfy the second one, because have a look. A to B, A to C, they are not parallel to each other. And from this graph right here, they are not collinear. They don't have, the 3 points are not on the same line. Whereas if A, B, and AC are parallel, you look at the first case, A to B, A to C, they are parallel, as you can see here. They're just on the same line because they're meeting the same, they have a common point A. So in this case, if you satisfy these 2 criteria, that means these 3 points are collinear. So how do you prove that? Very simple. So let's take AB and AC, as we already mentioned. How do you find vector A? B. So that's just OB minus OA. Simple vector rules. You take the origin to the second letter minus origin to the first letter, or first coordinates. OB in this case is 2i minus, I just have it in red, 2i minus j plus 7k, so that's OB. And OA would be minus 3i plus 2j plus 5k. So we're just taking the coordinates, putting in vector forms. That's it, in I, j, and k, because it's 3-dimensional. Okay, and what you get afterwards is 2i minus 3i would be 5i, minus j minus 2j would be minus 3j, and 7k minus 5k would be plus 2k. Okay, so that's the first point. That's vector AB. Now we need to find vector AC. And the common point here is A. So to find vector AC, that would just be OC. So O origin to the second coordinate minus origin to the first coordinate, which is OA. So let's have a look. What is OC? OC is 12i minus 7j plus 11k, and of course we subtract our vector A. So in this case, same thing, negative 3i plus 2j plus 5k. Okay, so once you do all the maths, you should get 15i minus 7j minus 2j is negative 9j, and 11k minus 5k, or minus plus 5k, would be negative plus 6k. Okay, and afterwards, that is vector AC. Now you compare vector AB to vector AC. So if you compare these two vectors right here, you can already see a relationship just by looking at it. 5i, 15i, negative 3j, negative 9j, and 2k, 6k. What does that mean? If you multiply AB, so here's the important part. If you multiply AB by 3, so you multiply this vector right here by 3, you actually get AC. What is the rule for two vectors to be parallel? One vector multiplied by a scalar equals the other vector. If that's the case, then those two vectors are parallel, and therefore you can conclude that AB is indeed parallel to AC. And since they have a common point which is criteria 1, and just have to know, you just say it at point A. Therefore, A, P, and C are collinear, and that's it. So you just have to prove two things. One, there are two vectors have a common point, and two, they are parallel to each other. Once you do that, guys, and you prove it, then you get that the 3 points are collinear. So that's pretty much it for today's tutorial videos, guys. If you have any questions, leave a comment, but aside from that, thanks for watching, and I'll see you next time.